Hi, everybody. So a bit of a introduction about myself. I started like what Patrick was talking about before. I started the Encode workshop that came before this, talking about the basics of blockchains, the foundations of blockchains, building a smart contract. What are the unique factors about Flare? So I think someone already shared that link in the chat there. That would be the source if you have any questions about the fundamentals, getting set up and getting crypto, working through what MetaMask is if you don't know already, and things like this. And I also touched a bit about FTC, um, the attestation types there, FTSO, and today's presentation is going to be focusing on FTSO and randomness on Flare. And just to give you a roadmap of the presentation, we're going to be talking about it is a workshop, so I'm going to spend about 15, maybe 20 minutes talking about FTSO, and then we'll go into some examples there. I'll spend some time talking about randomness on Flare, show some examples, and then talk a little bit about the Flare systems protocol, which integrates a lot of this. And then I'll leave hopefully around 10 minutes at the end for some Q&A. So let's go to what is FTSO. So FTSO, like Philip mentioned before, it's the Flare time series oracle. It's delivering decentralized time series data, mainly of asset prices. So you can get gold prices, commodity prices, etc. Mainly, we have the cryptocurrency price feeds that are highly available right now. And why do we need this to begin with? And I talked about this in the first presentation. It's because it's an iteration, it's a paradigm shift from the oracles you might be familiar with today, not relying on this smart contract model to get prices and data. We're getting the data from our validators, who also happen to be data providers. So they're providing this decentralized data infrastructure. Okay, and it's ensuring that the smart contracts are getting accurate data without relying on any centralized sources. Okay, so this is talking a little bit about FTSO here. It's not that important for what we're going to be discussing today. So you might see some of this as well, and it's important to touch on. So FTSO, we had a version 1, and that worked initially, but didn't scale well. So we had to figure out some of the gas usage and storage costs that bottlenecked its ability to expand. And the first version was limited to, I think, only 18 data feeds, I believe, with about 100 providers. And I think that consumed about 30% of sustainable gas bandwidth, and that restricted some of the growth. So this is important to say if you're just coming to Flare, or if you knew about Flare before, and this is before the update. So the scalability updates, it scales to 100 providers with about 1,000 data feeds. Okay, and it reduces the gas usage by about 10%. So that's important to say. So how does it actually work is probably the core question that you should be asking if you're not familiar with FTSO. It's providing this. Providers are calculating the medians off chain and then submitting the summarized results. And it uses the Merkle tree to create this fast verification of results. And only the root of that is stored on chain. And this is shown more on detail in the docs, which we're going to go to shortly. But it has these 4-step phases of committing to the results, revealing the Merkle tree and signing it, and then finalizing it. And that phase process is what ensures some of the security and accuracy in this process. Okay, and there are incentives. I think the last presentation I gave for Encode on FTSO, someone asked about the incentives, and there are rewards for the data providers that are submitting the accurate and timely submissions, and obviously penalties if they don't. And with V2, some of the core features there, so you have this off-chain computation part, and that providers are handling calculations locally, which reduces some of the on-chain burden. And then the on-chain verification. So like I mentioned before, the Merkle root is what enables the efficient, trustless, verifiable data verification. Okay, and that stops a lot of clogging up the network. So let's go to some of the examples that are available on the. I'm going to share this link with you in the chat. So let me share a different way. So everyone can go to that link here. And I'll share, let's see if I share the tab here. This should work. Yeah. So everyone can go to that link that I shared in the chat. And what we're going to do is just very simply walk through the code that's available here that you're most likely are going to be building off of when you start your projects. So if you want to go through any detail on FTSO, this has more than enough detail for you. Getting started section, sample smart contract, which we'll go through. You can also see the block latency feeds here, which you're going to be using in a few of the examples that I'm going to share with you. If you see the cryptocurrency prices, you have Flare USD, the category as well. Okay, so this is crypto. If you scroll down, you should see, we don't see them here. So there are some feeds for gold and a few others. Okay, so let's go to the interface now. So I'm clicking on the FTSO, FTSO reference, and the reference is going to show you the smart contracts on each chain. And then let's go to the interface. So this is how you're going to interact with FTSO in your smart contract. So this is crucial for you to look at when you are building your applications. And when you want to get the feeds, so I just showed you the feeds in the last block latency feeds previously, you can put it one feed in this method to get that value, right? It's going to give you to return the value, decimals, and timestamp. You can get the feed by ID in way. Okay, same kind of flow there. Get feeds by ID, so multiple feeds. Same thing, but in way. Then verify feed data, which we don't have to touch on today. But very simply, if you're following along, you can do the same thing I'm doing. Open that sample and remix. And we're going to let this load for a couple of seconds. And if you open it and you're following along, there's a couple of things I'd like you to do right now. So if you go to the, where is it? If you go to right in front of FTSO v2, you want to copy the test v2 interface, paste it there, and then change this function from payable to view. Okay. This is currently being updated in the docs. So it's very important for everyone to remember this because it's not going to work automatically. It's going to throw an error if you don't do these two things. So make sure that the functions are view and you're using this interface. Okay. So starting at the top of this contract, we're pulling in the contract registry, which exposes a lot of the smart contracts that Flare has developed. And this is how we get that contract here. Okay, so that's how we're pulling in the contract using the contract registry. And then we're pulling in the test interface. To be clear, this is a test import. So you're not using this in production. This is just demonstrating how to use it in a testing environment where I don't think we need this line here. We're exposing it and inlining everything right here, okay? And then returning the value. So I showed this last time using Remix. Once you have the contract, the next step is to compile that contract. So compile it and then deploy it. When you deploy it, you need to make sure that you're using the injected provider on MetaMask, or else it's not going to work properly. Okay, and you can see it automatically switches to the EVM version London. Philip mentioned this when he was giving an introduction. MetaMask, excuse me, Flare, it's an EVM layer one chain. It's a fork of Ethereum, and it's forking from the London fork. Okay, that's why you see it showing up here. So next step is to deploy this, and you should see, I'm not sure if you'll see the, on my right, I don't think you see this. It's bringing up MetaMask so I can confirm the transaction. So I'll confirm that, you'll see that it's pending, and then it went through. If you're familiar with using Remix, you'll see that the deployed contract is here, okay? And you can see the state value, the feed ID.
But are you, sorry, just to interrupt, are you on sharing the correct screen right now?
I'm sharing the...
We can see the developer hub. Oh, there. Okay.
Oh, okay, it didn't switch automatically. Okay.
I don't think so.
That's okay. That's okay. I'll go to, let's see. Yeah, so everything I was saying, so you were seeing the interface there. So I clicked on the open sample and remix, and then it brought me to what you're seeing in front of you now. It has a contract registry, the test interface, and I was saying before, this is a test interface. You're not using this in production. And the two things, this is something I'll say again because you weren't seeing the remix page. The two things that you're going to change is make sure that this is view, because when you press the open remix button, that's not a view, and then make sure that the test v2 interface is in front of the FTSO. It's currently not like that, and we have a PR open to fix that. So you have to make sure that you're making those two changes. So making sure it's view, not payable, and then adding the test v2 interface. Okay. Now the next step, if you're already familiar with smart contracts, is to compile. I already compiled it. You couldn't see it because it wasn't sharing this tab. And then deploying it by changing the injected provider to MetaMask. Deploying it, which I did already, and then it'll show you the deployed contract down here. You can see that it's already, the transaction was already confirmed. So what it exposes here is the feed ID, which is right here. This is the block latency feed for Flare USD, and then you can get the price from that. So this is the feed value that's showing there. Okay. So this is how you can use the get feed by ID. So let's go back and we'll show another example, just so we're on the same page. So this is what you were staring at before I was showing the remix. So let's make sure that doesn't happen again. Let's get the feed by ID in way. Okay, so open sample and remix. I believe I'm sharing the tab this time. Okay, and this is the contract that it's going to bring you. So remember the two things, so you don't run into any errors, is make sure that the function is view. Okay, let's do that. And then just copy and paste the test v2 interface there. Okay. Let's see, we don't need that. And this is the same flow. The only difference is that you're getting the feed in way, the feed ID in way. So same flow. Make sure you compile the contract now. Shouldn't have it. Yeah, no errors. Make sure that the environment is injected MetaMask. All right, and nothing in the constructor. I'm confirming the transaction on MetaMask, which went through, and now the same thing. So same feed ID, and then getting the value. It's getting the value in way. Okay. So let's go through, share this tab again. So that's the basic flow. Okay. And all of this is on the developer documentation. Just make sure you're doing those two things. And the last one I'll share with you is this one here, which is the feeds. Okay, so there's an S here, the feeds IDs. Let's do the same thing. Make sure you're bringing down the test interface. This is a view, and compile it. Okay, make sure it's injected MetaMask and deploy it. So this is the same flow that you're going to be following. Confirmed, feed IDs, and it gives you the feed values, comma separated. So this is Flare, this is Bitcoin, and USD. Okay, so that is the workshop, or the just going through the code here for using FTSO. And there's another, I put another contract in one of these tabs here. Let me share my screen for this tab. Let's go here. Doesn't seem to be loading, but this automated trader I was working on a smart contract that uses the current prices, and it's an automated trader that would execute a trade if the price is a certain level. If this loads on Remix, I can show you, but it doesn't look like that's happening. Okay, so that should be straightforward enough. I will go back to the slides and then go on to randomness on Flare. So randomness is important because you have, let me make sure I'm sharing this correctly. Okay, so randomness on blockchains. Randomness is important because most computers, or every computer, is a deterministic system. Okay, and Flare is using it in its Oracle infrastructure to create the unpredictable secure random values, which we're going to be demonstrating. It's part of the Oracle system, and to generate the random number, it's following this commit reveal scheme. So it's interesting because the Flare, the FTSO process, it's cleverly doubling as a randomness generator. Okay, and this is the flow of how it's working. We get it from the scaling protocol. It's relying on the commit reveal scheme. Then the providers are submitting a hash of their random number, then revealing it, and then the numbers are aggregated into a final random value. Okay, so you have the data providers that are generating a random number. Okay, this random number can be a number from 0 to 2 to the 256 power. And if you want a smaller number, you can also mod over it if you're familiar with doing that. Okay, and in Flare we have this, and the hash here is the random number is hashed. So it has the random number along with the address, voting epoch ID, and the price data. And with that, we can use random numbers in your smart contract. Okay, so we'll do the same thing. We'll be going over to the developer hub again. You can follow along with me here. If you go to the introduction, open up the network tab. I believe it's in network guides, and secure random numbers. So this will talk in more detail about what I mentioned about secure random numbers. You can read how it's the commit reveal and signing process and finalization process, which I briefly mentioned, goes through here. The hash that the data providers are committing to here, which I showed. You can read about all that here. So let's do the same thing. We'll walk through the secure random number on Remix and how to use that on Flare. If you notice from the previous examples, it's following a similar flow in terms of the contract registry and the interfaces. Right? So we're importing the contract registry here. Defining that in the function to make all the libraries available in the constructor, and then writing the function that's using the random number. Okay. This isn't inlined like it was in the previous example because we're using a constructor. So this is how we're getting the get random number function, and it's going to return the random number and is secure value, which is really important because this is basically a check to see that if the number is truly random. And if it's not truly random, then the data providers would be penalized. So it's basically a quality check. Then you'll have the timestamp. Okay. So let's go and compile this contract. Make sure you're on an injected MetaMask. No value here. Let's deploy it. MetaMask pops up for me. I think you can see this now. You can see MetaMask popping up for me. Confirm that. Okay. So let's use the function. And you can see that is secure is true. So this is a real random number. Okay, that big number right there. And like I said before, it can go from 0 to 2 to the 256 power. Okay. Now the application, the key application, the core application, I just touch on this one more time, is that the signing policy is using randomness because it's randomly picking the vote power block for the voter weight assignment. And that's what's ensuring the unpredictability in the protocol. And then we're using this for whatever we want. Okay, so I believe I have, this is the one that we just saw. So this is a guessing game, right? It's a simple use. I've already compiled this, but this is a simple use of the random number v2 interface, right? So we have the constructor here, pulled in the libraries. The constructor is setting a limit here of an arbitrary number, setting the max number, the generator, which is going to be generating the random number, and then this function here. And the way it's going to work is that when we call this function, we're going to input a number, and then it's going to do some simple checks. So if a number is above the max number that we set up here, then it's going to say, come back with an error message saying numbers only go up to that number, which in this case is 65,535. Above the secret number, which is the number that is the number that you're supposed to guess, because this is a simple guessing game. It says it's too big. If it's below the secret number, then it's too small. And if you get the secret number, it is correct. So just for fun, let's just compile this. Injected MetaMask. Let's set the, before I set the secret number or I set the max number to 12. So let's do that again. Or sorry, that is not what I want to do. That's where you set the number. Deploy it, confirm the transaction, and it'll show up on the bottom, right there. Transaction was confirmed. Max number is 12, which we set, and then we can guess that number. Okay. Let's see if I get it on the first try. 4, too big. 3, too big. 2, wow, too big. So it was 1. Okay, that was the simple guessing game there. And this is how you can use random numbers on the Flare network. Very simple code here. Just bringing it in. We're using it to generate this secret number, and then we create a simple guessing game with it. And this is where it's generating the number. Okay. So if it wasn't clear before, this is the generator. And that's pulling in the contract registry again, and then using that interface. Okay. So let's random this on Flare. And these are, we have a hard hat starter pack and a foundry starter. Maybe we can send this to you some other way, but you'll also find a hard hat starter in that repo if you want to do that yourself locally, along with some other helpful programs. So the last thing I want to talk about as we're coming up, I think I have a few minutes left. So the Flare Systems Protocol. So the Flare Systems Protocol is a core infrastructure of Flare. It's basically, another way you can think about it is the backbone for all of these enshrined oracles that we have. It's overseeing the voting, finalization, the rewards mechanism, and supporting the sub protocols. And FTSO, FTC, these are sub protocols on the Flare network, and it's what's integrating the randomness for secure operations. Okay, that's the core of FTSO. And what we have here is, whoops, maybe I can't show that. Okay, I can click on that. So Flare Systems Protocol. This is the Flare Systems Explorer. So it has the enshrined oracles that we can view in terms of the price feeds. It shows you all the price feeds that are available, that are provided by the data providers. You can look through that. We had Trump added recently. the Trump card, Sol, SHIB. So you can run through this and look at the price feeds that are available and that are being added. Sometimes there's a proposal in terms of the governance that everyone else can vote on, the data providers can vote on. So here are the providers, the data providers. You can look through this as well. FTC, the attestation requests that are being made, which I won't go into too much because I only talked about FTSO here. You can view the transactions. It has all the information for how the Flare system is running right now. So with that, I think it'd be a good time for me to stop and see what questions everyone might have.
Yeah, so if everyone wants to leave their questions in the chat, give people a couple of minutes to say if they have any. Okay, I can see a few people typing, so I'll be quiet in here.
So I also see a question, is it possible to automate get value contract calls? I mean, not needing to invoke them manually. I'm not sure what the question means. Automate. What exactly is a get value contract calls?
Do you want to clarify your question, Jess?
Sure. Let's yeah, so the random numbers, they're generated by the protocol itself. And you have this, it's exposed by the FTSO scaling protocol. And data providers are the one that generate that random number. And they're required to submit a random number for every time they submit a price to FTSO. And then that's a way that's exposed is through the FTSO or through the random interface that I showed through the guessing game. And then we can pull in that method through the contract registry and then use that random number that's being generated by the protocol. So hopefully that answers Michael's question. Is JSON API support added to Costin 2 for FTC? Not 100% sure about that, but it is, I think it is on a Costin 2. I think that's what I demonstrated the last time. And I know if that's your name there, you can look at the playlist where I went through FTC. I can't remember if it was on Costin or Costin 2. I can check that. Cron jobs, okay, interesting. I had one regarding cron jobs earlier. Can FTSO or FTC be used as cron jobs to trigger something? That's a good question. I'm not sure. I think it could. I don't think we've thought about doing that before. I'm also not aware of smart contracts that are currently being run by cron jobs. I think you'd have to automate some of the MetaMask confirmations of transactions, which may not be the best thing to do. But I'm not fully aware of cron jobs. Can we get some use cases of how Flare can basically be used that can aid development on our end as devs? Oh, sure. So let me put in the chat real quick. We have starter packs. Actually, I'll link them in from the developer hub. So you'll see here that we have a hard hat starter pack. You can clone that down and start using the Flare functionality locally. I think it should take you only to hard hat. We have a PR that's going to add support for, not support, but showing the documentation in more detail, the hard hat how to use the hard hat starter pack and also Foundry. You'll be able to switch between 2 tabs, which should get merged tomorrow. I think liquidation bots in DeFi are triggered by external calls. Oh, interesting. Okay. Yeah, I'll look into that. I haven't really thought about cron jobs. Okay. Let's wait for JS there. See, JS is typing. So you're asking about specific dApps. I don't have specific dApps off the top of my head being used. The guessing game is a very simple example that I ran through that hopefully demonstrated a simple way you're pulling in the random number. So hopefully that would make sense for you. So this is I'll answer this broadly because it might answer more questions. So Flare Flare is a fork of the EVM. So if the EVM supports it, then Flare would support it. Okay. So everything you can do on an EVM chain, you can do on Flare.
Okay, I think that addresses all the questions, right? Yeah. Okay. So yeah, thank you, Anthony, for the talk, and thank you, everyone, for being a part of today's session. Tomorrow, I believe we'll have another one on Flare Data Connector for connecting and using Web2 APIs in your dApps. That will be, I believe, exact same time. Yes, same time as the launch started today, tomorrow. So yeah, I look forward to seeing you all there. I will end the session now and see you all tomorrow. Bye.
Thanks, everybody.